All right, 6.2, radicals and rational exponents. So starting off, you can read this on your own. I'm going to kind of summarize it. We can generalize or we can extend the square root, right? We know that the square root of 4 is 2, right? Because the square root is so important and so normal, we never put the little 2 there to say that it's a square root. But there's an understood 2 there saying it's the square root. We could have a cubed root of, we'll say, 8, and that's asking what number multiplied by itself 3 times would be 8, and that would be 2, right? Because 2 cubed is 8, right? These two are very similar statements, okay? So we kind of extend the concept of the square root to other kinds of roots. What else do we need to know? If we have something like b to the n equals a, that's like saying that 2 cubed equals 8. Then the nth root of a, b is the nth root of a, right? You need to get used to saying the things like nth root or fifth root, okay? Whenever we have things written as a root, it's called radical form. The other way would be exponential form. What we're going to be doing in this lesson, and I think it's written out really nicely somewhere else, is we're going to convert from roots to exponents. This would be 4 to the 1 over 2. And we'll have that listed there later on, okay? All right, some things that we need to know. If n is odd, so n is talking about what kind of root it is, like the square root would be an even root, the third root would be an odd root. If n is odd, then a has one real nth root. And the nth root of a is equal to 1 over, or excuse me, a to the 1 over n, right? That's kind of what I showed you earlier. If n is even, and a is greater than 0, then a has 2 real roots. You have to write them as plus or minus the nth root of a equals the plus or minus a to the 1 over n. If n is even and a equals 0, then a has 1 real nth root. The nth root of 0 is 0. If n is even and a is less than 0, then a has no real nth roots. All right, and what are all these meaning? This bottom one, it's probably the easiest one. So it's talking about even. It's saying that the square root of like -4 does not exist, right? There's no square root to the -4 there, right? That's what that's saying. -4 is less than 0, so it's saying it has no root. Working our way up, we're looking at the 0 one. That one should kind of make sense, and we should be okay with that. Looking at this one here. What this means here is that if you had the square root of 4, you could think about that as being 2 or -2, because 2 times 2 is 4, and -2 times -2 is 4, right? It makes it positive. Now, my general rule for these is that if you're doing a math problem, if you're doing a problem on the homework, and you create the root, like you write the root in there, or you write the exponent that is a root, right? If you write this piece in there, then you have to worry about the plus or minus, okay? If it's already written there for you, then you're good. So pretty soon on examples number 11 and 12, we're going to write in the root, so we're going to have to think about the plus or minus. All right, so example number 11. It says that n equals 3 and a equals -64, and we're supposed to find the nth roots. So this is going to be the third roots of -64. And now that we wrote the root just now, we have to think about, are we going to need the plus or minus? Well, this is a cubed root, a third root. That's an odd root, so we do not need the plus or minus. The cubed root of -64 is -4, and you can type that in the calculator. A way to check yourself would be to take negative 4 to the third. Well, that's negative 4 times negative 4 times another negative 4. The first two negatives cancel, right? Because a negative times a negative. Then we have the leftover negative. That would make this guy negative. And then 4 times 4 times 4 is 64. All right. Moving on. We'll say example 12, n equals 4 and a equals 625. Let me see if I can, there we go. So this is going to be the fourth root of 625. Now we wrote the root in, we have to decide, do we need a plus or minus? And in this case, we are going to need a plus or minus because this is an even root. The fourth root of 625 is 5, but we have to have a plus or minus there. To check yourself, you can say, well, 5 to the fourth is 625, and negative 5 to the fourth is also 625. Because if you wrote this out, let me write it out, we would have the first two pair of negatives would cancel each other, and the second two pair would also cancel each other. So it would end up being positive there. All right, example number 13. This is the fifth root of negative 243. Now, we did not write in the root, right? In these two problems up here, we wrote the root in there. We didn't write this root in there, so we don't even need to think about whether or not it has a positive or negative. The fifth root of negative 243, well, that's going to be negative 3. And let's think about why that is. This would be negative 3 5 times. The 3's, it should be pretty easy to see that that's going to be 243. If we multiply just the 3's together. Negative and negative goes to positive. Negative and negative goes to positive. And there's a leftover negative, so we're going to need a negative there. Right? We should be seeing that if it is an odd exponent or an odd root, the negative carries through, right? This guy right up here, that is odd, so the negative carries through. There's a negative there, and there's a negative there. Example 14, this is the fourth root of negative 625. Well, that is no solution. All right, and let me give you an easier problem. Square root of negative 9. Well, we know that the square root of negative 9 is no solution, right? There's no two numbers that multiply together to be negative 9, right? There's no four numbers that multiply to be negative 625. Rational exponents. Oh, good grief. Let me see how I want to write this. We're just going to look at this top line here. We're not going to worry about the bottom line. Actually, excuse me. We're not going to worry about this thing here. It's written the same way, just a little bit different. This says that a to the m over n would be equal to a to the 1 over n times m. So all they did was they separated the fraction apart. You could say, well, that's equal to a to the 1 over n to the m. And then you could turn that into a root by pulling the n out front. The thing we should notice is the denominator becomes the root. The numerator stays in the exponent. Okay? And that could be written also as the nth root of a to the m, where the m is underneath the root. Right? We can decide if we want the m there to be under the root or outside the root. Sometimes it's more beneficial to be under the root, and sometimes it's more beneficial to be outside of the root. So the bottom piece here, what this means is that 27 to the 2 over 3, the 3 becomes a root, and then we have 27 squared left over. And that could be 27 squared with the 2 under the root, or 3 to the square root of 27 squared with the squaring on the outside there. All right, example 15. No, we don't need more space. The 32 to the 2 over 5. Well, that's going to be the fifth root of 32, and I'm going to put the squared on the outside of it. Right. As you do these problems more often, you'll end up seeing where you want that square to be. The fifth root of 32 is 5. Not 5, 2. 2. And then we have squared, right? So this whole piece turned into 2, and then I just carried the exponent out. 2 squared is 4. Example 16. Well, this will be the same thing as 4 root 81. I'm going to put the cubed on the outside. Well, the fourth root of 81 is 3. Now, we're not going to worry about the plus or minus because there's a 4 there, but we're not going to worry about the plus or minus because it was already written, right? Even though this does not look like a root, that is a root, right? It's equivalent to a root. It was written as that before we got to it, right? We did not write that in there, so we don't need to worry about the plus or minus. So where was I? This thing turns into a 3, and then we have cubed. 3 cubed is 27. Here we have the square root of 25 cubed. Well, the square root of 25 is 5 cubed. 5 cubed is 125. Example 18, evaluate 27 to the 2 over 3. That's going to be the cubed root of 27 squared. Well, the cubed root of 27, this is supposed to be negative right there. All right, and that kind of changes some things. We'll put a negative under there as well. The cubed root of negative 27 is going to be negative 3, and then squared. Well, negative 3 squared is going to be 9. Example 19. This is supposed to have a negative out front and a negative underneath. So starting off, I'm just going to copy down that negative, the first negative. The cubed root of negative 27 is negative 3. So this thing here turned into a negative 3. And then we have a negative, which goes to a positive 3. Alrighty. Example 20. This is similar to some problems that I've seen on the PSAT and the SAT. We don't necessarily know how to use this formula that it gives us, but we can just trust the formula and we can plug in. So it says, to calculate the annual inflation rate, R, in decimal form, of an item that increases in value from P to F over a period of N years, you use the equation there. Find the annual inflation rate of a house that increased in value from, so from is P, right? Yeah, P equals 300,000 to 360,000 over a period of 8 years. So it wants us to find the inflation rate R, right? This is R. And all we're going to do is we're just going to plug into that formula. So we're going to have, well, R equals F 360,000 over P 300,000. And then it's 1 over N, so 1 over 8, and then minus 1. Well, you can just type that in a calculator and it will give you R equals 0.023. So that's written as a decimal form, and to convert it to a percent, you move the decimal point 2 spots, so this is 2.3, and then you put a percent symbol after it. All right, and that's it. The hardest part of this problem is probably knowing how to type that in the calculator, right? And there's some videos on that. What I would do if I was typing this in, or whenever I did type it in, I canceled out 4 zeros on each of those just to make it a little bit faster to type in. Um, and the rest of it you just kind of have to do. So I'd do 36 over 30. I'd have parentheses around it, and then I'd use the caret button, the exponent button, and then 1 divided by 8. And then I'd probably press enter there, and I'd subtract 1 from that. If you have trouble with that, let me know during class, and I'd be happy to help you with that. All right, so that is 6.2.